away from the mean is that you've been technically giving me a z-score when you've told me 2 standard deviations away or 1.5 standard deviations away. So the z-score is nothing more than the number of standard deviations from the mean. A couple things. If it's a positive z-score, that means it's above the mean. If it's a negative z-score, that means it's below. Okay, which you see on your chart. Negative z-scores are below, positive z-scores are above. Okay, so on this particular example, we have a mean of 86 and a standard deviation of 3. So there'd be 89, 83, and so on. 80, 92. Then an 80% is what z-score? How many standard deviations away from the average is it? -2. It's 2 below. So that's just a z-score of -2. So what we were doing yesterday could have been done in our head. But like we just saw with the example I gave Cameron that he got correct, it just can become more difficult. So there's just a formula for that. This is your data value minus your mean over your standard deviation. So even though we could calculate this one conceptually, the formula would be z equals the data score was an 80 minus the average was an 86. See how that's what's going to give you the negative z-score over the standard deviation of 3. So that's -6 over 3, which gives us a z-score of -2. So when we jump into exercise 1, we're given boys' heights in 7th grade are normally distributed with a mean height of 62 and a standard deviation of 3.2. So that's kind of 65.2. If I go down 3.2, that would be 58.8. Find the z-scores rounded to the nearest hundredth for each of the following heights. So like you can see clearly here, this is going to be trickier because 66, it's a little more than 1 away, but it's hard to see exactly how much, right? So we would just use this calculator here to do the z-score is 66 minus the average of 62 all over the standard deviation of 3.2. Because the reality is also yesterday a lot of our standard deviations were whole numbers, which was just a nice feature. But realistically with statistics, your standard deviation is very rarely a whole number. We just start with whole numbers to help you develop your conceptual understanding and not overcomplicate. But this would just be 4 divided by 3.2, which is a little over 1 standard deviation away, so that's a z-score of 1.25. Okay? 57, approximately, what do you think the z-score would be? Try to come up with the approximate guess based on what you know conceptually before you start crunching numbers. That way you know if you're way off, if you crunch wrong. So 57, Kaylee Smith, what would be your guesstimate? Wait a minute. Well, here's 1 standard deviation. Right, so it's more than 1 away. So it would be like -1 point, right, a little bit further. So, oh, you went the wrong side of that, yeah. So it should be like -1 point something, and then you just do your math, 57 minus 62 over 3.2. Make sure you do your subtraction on your numerator first. So this is going to be -1 point, it says to the nearest tenth, right? So, oh, nearest hundredth. -1.56. Okay? 70 looks like it's going to be at least 2 above. So I'm expecting 2 point something. So that would be 2.5. Okay? So z-scores. Any questions? We've been doing it. Now we're just putting a name on that. When we've been kind of correlating it to that number of standard deviations, that's the z-score of that number. Okie doke? All right. So what to do with these z-scores? You all are going to need a calculator today. So if you don't have one out, get it out, or go up here, quickly take 30 seconds to go grab one. Exchange something for a calculator. The next exercise here has us kind of go backwards. It tells us the average score, 560, and a standard deviation of 45. So this would be 605, 650, 45 backwards would be 515, and so on. Jeremiah's score, they tell you the z-score is 1.84. So he's 1.84 units above, right? 1.84 standard deviations above. So he's somewhere between a 605 and a 650. We can gather that. But to be precise about it, just go back and use your formula. You know the z-score this time, so 1.84 equals. Your data x is what you're looking for, so x sub I, minus the average of 560 over a standard deviation of 45. So what do I do first to both sides to solve this, Aiden? Multiply that 45 over, correct? That's going to give us 82.8 equals xi minus 560. And then obviously just add your 560 to the nearest whole number. He got a 643. So that would be, so this is like SATs, if you're talking scores like that. 643, which is pretty timely because you're all thinking about SATs these days. And that's about where we thought. We knew it would be somewhere between 605 and 650. So just being able to use that backwards. Okay? So that being said, I think we have to add a flashcard, don't we? Z-score. Oh boy, I need a new sheet of paper. So I'm going to put the z-score formula on there. If we jump down to exercise 3, the lengths of full-grown sockeye salmon are normally distributed with a mean of 29.2 and a standard deviation of 2.4. So 2.4 above would be 31.6. 2.4 below would be 26.8. I'm not going to do too much more than that. Using z-scores, and this is a new skill, so you're not going to know how to do this. Determine the proportion of the sockeye salmon population to the nearest percent that lies between 26 and 32. Now, if they had told us 26.8 and 31.6, we could do that, right? We could go right to our chart. One standard deviation below, one standard deviation above. But we're a little more than one below, and we're a little less than one above is the window that they're looking for. Your chart only does so much for you, right? What happens if you're 1.1 below? Your chart doesn't do that for you. Guess what? Your calculator does. So there is a function on your calculator that is always going to be used to figure out the area under a curve, or the percentage of a population under a curve. And the first two numbers are the lower z-score, so the z-score of the 26. We have to calculate that. So z equals 26 minus the average of 29.2 over the standard deviation of 2.4. So that's a z-score of negative 1.3 repeating. So there's your low end z-score. Your high end z-score is the 32, so we got to come up with what that one is. Oh boy, 32 minus 29.2 divided by 2.4. That's a z-score of 1.16 repeating. I'll show you where to type this into your calculator in a minute. And your average Okay, so here's what we're doing. We're going to tell our calculator that we want to find the area under the curve from negative 1.3, repeating, which is right around here, all the way up until 1.16. Okay, so we're looking for the area between those two benchmarks. And then you have to tell the calculator what's your average standard deviation, so that's always going to be 0. And what is your standard deviation? And when we've changed everything to z-scores, our one standard deviation is 1. So on your calculator, here's where you find it. There's this VARS button, but above it it says, well, in short for distribution. So you're going to hit second in that VARS button, and you'll see it, Normcdf. It's the only thing from this menu we're ever going to use. Normcdf, it's the second option. So, yep. Second, and then this VARS button next to the clear. So we're just going to type in lower, negative 1 point, and put a bunch of 3's in there because it was negative 1.3 repeating. On the high end, it's 1.16 repeating. And then it's 0 for your average and 1 for your standard deviation. And then paste. And it's going to, if we round this, what does it say? To the nearest percent, what's that? 79%. So equals 0.787, which is approximately 79% of the population is going to fall between those two. Okay? Our chart can only do so much. Our chart is only conducive to exact standard deviations of 1, 1.5, 2, 2.5, and so on. Okay? Here's the thing with z-scores. If they ask you a question like that, you have to know z-scores. If it's an open response and they say using z-scores, you have to do that. But the reality is, I haven't seen too many that force you to use z-scores, and they will just say determine the proportion. And you don't have to do the z-score translation, and I wouldn't if you don't have to. All you have to do, so let's pretend this didn't say using z-scores, between 26 and 32, so your lower end would be 26, your higher end would be 32, your average was 29.2, and your standard deviation was 2.4. And it's going to give you the same answer. So why convert it if you don't have to? Okay? So there's definitely a need to understand z-scores, and that one z-score is one standard deviation above the mean and so on. But I honestly haven't seen too many places where they forced it upon you. So in general, unless it says that, just type in, and I want you to write this in your notes right now, just the other version of this, because it's much more straightforward. There's no work. We're going to do 26, 32, the mean of 29.2, and the standard deviation. And your calculator tells you exactly what number to put in each spot. So, and I'm just going to also remind you that that comes from second. There's Nathan Henry question. Yep. But just the way they phrase the questions would just, oftentimes it's just what proportion falls between these two numbers. You don't need to convert. Okay? If you do convert, though, your average is always 0 because you've normalized it to be comparable with any statistic. So you use a 0 average and a 1 for your standard deviation. But I'm going to push you in this direction. Okay? So then there are a couple, and we're going to go with this way moving forward here. Determine the proportion that measures less than 25. Now that's interesting. So if I look at this chart that I sketched, less than 25 is anything here or below. So in a case like that, you really want anything from negative infinity up until 25. You follow? You have to give the calculator a low end, though. You can't say from as low as possible up until 25. So when that happens and it's kind of like to infinity, your low end, just to be safe, make it negative 999. Not that we would ever have a fish that is that small. That doesn't even make any sense. But that just tells the calculator pretty much anything to the left. As far to the left as you can possibly go up until 25. And then again, our mean was 29.2 and our standard deviation was 2.4. So go ahead and type that into your calculator. I don't expect it to be very large. And it's not. I got 0.04, which is about 4%. That should make sense because look at your chart. Look at your graph up here. 26.8 is already one standard deviation away. So if you go down to 26, you're like kind of down in this range. Yes? You're only looking at these small percentages. So I did expect it to be pretty small. Oh, not even 26. We're going down to 25. So we're almost more than 2 standard deviations away. Okay? And then greater than 35 inches, look up here. 35 is going to be here. We want the proportion, anything that's greater than 35. So when I do my Normcdf, what's my lower end? 35. My upper end? Positive 999. To kind of tell your calculator that you're going to infinity. So one more time, Normcdf. Again, I expect this to be pretty, almost teeny tiny because that's multiple standard deviations above 35 to 999. And I get 0.0078, which is about 0.78%. So less than 1% of the fish will be that big. Okie doke? Any questions? Let's jump to the, like just a multiple choice. Average weight of full-grown beef cows, given. Standard deviation, given. If the weights are normally distributed, what is the percentile rank? So, again with understanding percentile. The average is 1470. The standard deviation is 230. So I'll just do 1470 plus 230. 1700 is one standard deviation above. And 1240 is one below. They want the percentile rank of a cow that is 1750. So that would fall right about here. Who can tell me what they think we should do here? When you're asked for the percentile rank, what are you being asked for? Which area under the curve? Okay, if I tell you you're in the 80th percentile, Maggie, what does that mean? %, of that half of the chart, so 80% of the 50%. If I tell you on the last test you were in the 80th percentile, what does that mean? Is that good? Yeah? Why is that good? Okay, but you, Cameron, elaborate on that a little bit. You're in the top 20%, but the 80 means that you scored better than 80%, okay? So this cow's weight is greater than what percent of everybody else is essentially what you're asking. So you want to know what is the percentage that falls in this range so that you know that this cow is better than what percent of the other cows. Now, just looking at your options, 3 and 4 should be ditched, right? But to get exact, Normcdf. And what are my numbers, Evan? What's my low number that I'm going to use? 1010? Nope, I want the lowest number I can put since I'm going to negative infinity. Yes. Up until what? This is going up until, where's this number? Read back. Nope, I'm a little past 1700. Because I want to know the percentile rank of a cow that's weighing 1750. So that line that I put there is at 1750. Isaiah, what comes next? The mean. The mean actually comes first. Yep. 1470 and then the 230. So go ahead and type that in. 999, 1750, 1470, 230. Lydia. Because you can't be lower than 0. Because sometimes 2 standard deviations away on the lesser side of things will put you in a range, just by the way the data numbers work out, will put you, below that. Probably not in this case, to be honest, but just to be safe, because that sometimes does happen, whereas like scoring 2 standard deviations below the average isn't even possible. Because it does happen, you still want to include those as your percentage under the curve, your area under the curve. So we just are safe, and we don't really think about it logically. We just say as low as you can go, negative 999. And we get this 0.88, which is the 89th percentile. Okay? So sometimes they'll be very straightforward. What's the percentage between these two numbers? Sometimes they say less than a number. So you have to go from negative 999 up to that. Sometimes they'll say greater than a number, and then sometimes they'll ask the percentile. And in all of these cases, we're doing that Normcdf. You are going to have a quiz on stats on Thursday. And it's through this stuff.